This conference will now be recorded.
And thank you so very much. So, dear friends, let's take this particular session not as a unilateral session, but of course, a bilateral session, a communication based session, wherein my intention is, of course, to address all your queries, to introduce you what with this particular technology called VXLAN, virtual extensible storage, not storage, local area network. There is storage area networking also, which we do take. So this is called VXLAN, virtual extensible local area network. We are going to talk about in this particular technology what exactly is this with regards to its topology, right? With regards to the difference between the underlay and overlay, why this difference is required? Because VXLAN is an overlay technology. The earlier technologies, right, for the networking purpose, like the technology routing, basic routing, right, is our underlay. How do we achieve it? We do achieve this with the help of various routing protocols. And so it is expected you guys to know about those protocols, those routing protocols. So expectation is you guys should know what is routing information protocol, what is OSPF, what is EIGRP, what is BGP. In this particular technology, we will be talking about, in terms of implementation, configuration, two of these underlay protocols called OSPF and BGP. So I'm just setting up the expectations in terms of our basic understanding that we should have the basic understanding of OSPF and we need to have basic understanding of BGP before stepping into our deep dive understanding of VXLAN. The VXLAN is an overlay technology. Overlay is what? Overlay is nothing but it is a tunneling technology. So we are going to create tunnel on top of our pre-existing setup, and the pre-existing setup is nothing but it is underlay. So my dear friends, over here in this particular VXLAN course, you are going to understand more about how to create a tunnel, end-to-end tunnel. Then the question comes is, you know what? The question comes is, why do we need this tunneling? Pretty important question. Today, we are living in the cloud world. So that is what is going to be addressed. So when and wherever the terminology called cloud comes, it becomes important for us to understand the cloud connecting technologies. VXLAN is that industry standard technology which helps us to achieve the cloud-based connectivity. Dear friends, right? I just have said VXLAN is industry standard. This is not any vendor's proprietary technology, but our focus will be to take the help of one vendor, right, and to implement this technology using his devices, and that vendor is nothing but Cisco. I do have a long relation with Cisco, more than 2 decades old relations with Cisco. I have given so much to Cisco, and Cisco has given me so much back in return. And thank you so much to this relationship. All right. So, you know what? I'm expecting someone to ask a question in between. So, I would like to put my pen down and would like to move on to you guys. Any question? Please do interrupt me. I love to get interrupted. Okay. Anytime you can unmute yourself and you can ask, you can raise the question. As I said, I love to hear back from you. Any question of your choice.
Yeah, hi, I am Harshit. Hello.
Yes, please. Hello, yeah.
Yeah, yeah. Can you please explain me again what is tunneling? Means what type of tunneling we are using in VXLAN? Can you please explain that?
Oh, very important question, Harshad, you have asked, and that's definitely part of my agenda of the day. Tunneling or overlay. What I'm going to explain you shortly
Yes.
over here are going to be of three different
Mm.
types, which is coming shortly. Okay. Yes, good
Okay,
question.
perfect.
I have kept this question aside for this question to be addressed with so many other questions. Dear friends,
Okay. Yeah.
any other question? All right. No worries. I know that question from one friend is becomes the question of all. So guys, after this, let me just cover up the agenda. I'm going to talk about the VXLAN. What is VXLAN and its evolution? We are going to talk about various terminologies to be used in VXLAN. We are going to talk about various deployment modes in VXLAN. Deployment means configuration modes. And finally, we will be talking about in this particular technology, the beautiful deployment mode of VXLAN, which is called MPBGP, address family, EVPN, deployment mode of VXLAN. So quite imperative. Before we reach onto this particular topic in our VXLAN, I would like to give you a gift of a master author to make yourself comfortable with, or in case if you need to refresh yourself with regards to your understanding on BGP. He is my guru, right? With whom I learned BGP deeply, and he is none other than Sam Halabi. I will give you this particular book as a gift before stepping onto this. So how you are going to get, I will tell you that shortly as well. Okay. So my dear friend Harshad has asked a question. It's my responsibility to address him. And his question is, what are different kinds of tunnels created in VXLAN? So guys, the architecture which we do follow respect in VXLAN. In short, the architecture is called clause-based architecture. It was a gentleman called Charles Claus who formalized this architecture in the year 1953. I didn't say who developed this or designed this architecture. The holistic design of this switched network was done way back in the year 1938 by a gentleman called Edson Herwin. Today, this architecture in industry is known as spine and leaf architecture. This particular architecture, the beauty of this particular architecture, this architecture is absolutely a loop free architecture by the virtue of its connectivity. Unlike our traditional or a legacy architecture which we are using, the architecture, right, of our switch connectivity, this is our legacy or classic architecture. This particular architecture triggers in a protocol. Guys, can you tell me, if switches are connected in this particular architecture, what particular protocol gets triggered in automatically in our switched network? Yes, please.
ST STP, STP.
Absolutely. 100% correct. This is STP, spanning tree protocol. But do you see in this particular architecture, this is the old and the legendary architecture created way back in the year 1938 by Edson Erwin, later on formalized by Charles Claus in 1953 and adopted by whom? Adopted by Bell Telephone Company. Today, history has repeated itself And we have this particular architecture back again with us in our technology called VXLAN. Not only in VXLAN, even in SDN, software defined networking, we use this loop free architecture. So this is the beauty. This particular architecture says spanning tree protocol, you are not allowed, which doesn't mean that STP is not available, which just simply means I have not given leverage to you, Mr. Spanning Tree Protocol, to act in my or interfere in my architecture. But in case if I happen to see that you are interfering in this architecture, then we have smart network administrators who are given smart commands to immediately shut you down. This is what we are going to see in VXLAN, and of course post VXLAN a technology called ACI. How? That I will tell you. Well, would like to keep you. The connectivity, I'm just trying to show you how the connectivity is done. Guys, we have to respect the time, right? So please feel absolutely free if you want to ask a question. We were talking about underlay. Underlay is nothing but it is an internal connectivity, the connectivity which is predominantly required in order to create any tunnel. How do we achieve it? All of you guys are from CCNA, CCNP background. All of you guys know the routing protocol. This connectivity is established first of all. Number one, physical connectivity. Number two, IP addressing. Number three, routing protocol. Do it. Make sure the layer 3 reachability between all the nodes participating into it is established, is reached. So this is called underlay. Once this underlay is prepared, is done, then we come over to the overlay, right? In case of underlay, we use different terminologies, pretty known to us. Of course, physical connectivity is there. Of course, IP addresses are configured. Of course, we have layer 3 interface pairing. We have the switches called edge devices. We have LAN segment, etc. Once we have this underlay ready, then on top of the underlay, what we create is called tunnels. Tunnels with the holistic object to make sure that this particular node, they, not practically, but logically, they find themselves as if they are directly connected, though they are not directly connected. The purpose of tunnel is to take the help of the path and bypass the path. That is, we are taking the path, this particular path, but we do not let any other guy to know the direct relationship. So apparently the devices or the endpoints which are connected to each other, they find themselves as if they are directly connected. Guys, VPN is a classic example of tunneling. Virtual private network, not at all a new technology, but there are certain inherent challenges and the advantages in VPN. VPN is basically meant to provide a secured communication end to end. Secured means encrypted communication from one end to another end, but has certain challenges. Those challenges, what are those challenges? The layer 2 and layer 3 reachability. What are those challenges shortly known as? Guys, I'm just giving you a terminology. Don't get confused because the details of the terminology, how it works, will be coming up later on. This is called IRB. VXLAN is what provides us integrated. I stand for integrated, R stand for routing, and B stand for bridging. This is the beauty of VXLAN, provides us integrated routing and bridging. What is this in detail? In its anatomical form, we will be discussing during this particular journey. All right, so it is my holistic responsibility. I promised my dear friend Harshad that I'll tell him what are what is overlay and what are different types of overlay. So dear friends, you can
I
see
have a
over here.
question. I have a question, sir.
Please, please.
If you go to the previous slide that you have shown,
Yeah, sure.
previous slide that you were
Yeah.
discussing, yeah, in this one. So actual control, like if we understand the edge devices which are in circle, so those are getting the routing information, like all the routing is done via spine switches, but actual data plane is like the tunnel that we have created between the endpoints. So data traffic will flow via tunnel, but all the control connection will take forward through the spine switches.
You are right. I can give you more details of it. Okay. Since you have raised this concern, dear Prashant, so let me tell you what is the routing component over here, which VXLAN provides. First of all, for example, this particular device belongs to a network 10.0.0.0/8, and this device belongs to a network 20.0.0.0/8. So both of these endpoints, they belong to two different networks, right? The details of this particular network and this particular network need not be known to the spine switch, right? So we need not, in other words, we need not advertise this network into the spine switch. We need not advertise this network via its connected VTAP into the spine switch, but still these two devices and in different networks, they can talk to each other. This is what VXLAN provides. How it
Uh,
happens, how the information gets propagated, that is nothing but that is the VXLAN. In other words, this particular device, which is acting as a central or the hub device, need not advertise, need not route these traffics in the routing table, but still the routing communication happens. Who is responsible for it? It is done by VXLAN. Prashant, I am not promising you that you have understood it, because there are a lot many other things, inherent and anatomical things, which we need to explain,
yeah, sure, sir, sure. Thank you.
right? Okay, and during this particular journey of VXLAN, which will spread across 2 weeks time, well, we will be talking very deep into VXLAN, as much as depth we can. All right. Okay. So there was a question earlier, and you know what, Prashant, thank you so much for asking this question in between. You have holistically used your fundamental right to ask a question. Okay. Now, overlay is synonym of tunnel. We need to understand what different kinds of tunnels can be created using VXLAN. Of course, we don't call it to be as an IPsec tunnel. Unlike in case of a VPN, VPN provides us IPsec tunnel, of course, where payload gets encrypted, where the authentication happens, and even it is an encrypted authentication which happens. But VXLAN is not focusing towards IPsec. Okay. Now, but VXLAN provides us a leverage to create tunnels using different kinds of devices. Over here, the devices can be the physical devices. The devices can be virtual devices. Devices over here means switches. So switches can be physical, switches can be virtual, switches can be a mixture of both physical and virtual. So there is something which I would like to show you, but the font size of the particular component is very small, so I am going to remove my presentation from slide share mode to just a general mode, so that I can zoom it, can bring it to a big size. So here we go. I'm zooming in. I am zooming into a specific overlay, and this is nothing but this is called my network overlay. So over here in the network overlay, what do you see, guys? We have the end devices, edge devices, better to call them as. In VXLAN terminology, we call them as our VTAP devices. Let me grab my pen quick. Yeah, grab. I'm talking about this particular device, this particular, and this particular device. There is this dotted line arrows. This is nothing but this is signifying the tunnel. I'm sorry, it's L, not T. So what kind of tunnel it is creating? It is creating a network tunnel, right? Network overlay, we call it. Why we call it as a network overlay? Because this overlay is being configured using our physical devices. All these devices, what you do see, they are our physical devices. Below the physical devices, we do have our endpoint devices. These are nothing but these are our servers. All right, so these servers may be our one second, let me go to my pointer, and all right, so these servers are the ones which have the endpoints configured inside it, and via these VTAP devices, VTAP stands for VXLAN tunnel endpoint, we do establish the connectivity between the devices. This is called network overlay. Then our next kind of overlay is known as host overlay. Dear friends, kindly take a note over here. Our VXLAN edge point device called VTAP is moved down. It is not configured on this device, which is a physical device, but it is configured on a virtual device. This virtual device is nothing but this is virtual device, or you can call this to be as a virtual switch. Those dear friends of mine over here, if you have done VMware NSX training or implementation or deployment, etc., you should be knowing that in VXLAN, I'm sorry, in VMware vCenter, we have a virtual switch called virtual standard switch. In a distributed environment, there is a better one called VDS, virtual distributed switch. Dear friends, this particular switch, these are those distributed virtual switches. They are absolutely capable to behave in the same way. This, how do they work? How do we configure them? Is a part of network virtualization, which we do cover in a separate topic called SDN. Cisco's terminology is in Cisco's terminology, we call it as a Cisco application centric infrastructure. How these virtual device, virtual distributed switch works, configured, etc. We will be talking about over there. But with regards to VXLAN, and that too, when we are talking about host tunneling or host based tunneling, also known as host overlay, the VXLAN configuration is done on these devices. Kindly be noted one more point over here. What we have mentioned, this is called a hypervisor. Hypervisor is that abstraction layer between kernel and the virtual machines, which provides a leverage to the hardware device to configure multiple virtual machines on top of one single hardware machine. What is this? This is nothing but also we are going to talk about in Cisco ACI, right? So please, you have to give me an excuse to go more detail into it during VXLAN session. I will not be able to give you a detailed understanding of what is hypervisor, what is this, the virtual distributed switch and all. Okay, so when we create our tunnels using our virtual switches, that particular tunnel or overlay is known as host overlay. Hope it makes sense. Guys, in order to respect the time, you know what? I have to shorten because I have to show you where exactly and which lab we are going to use. So I have to shorten my explanation, but you should not squeeze your questions in case if you have. Okay, network overlay, host overlay. Combination of both of them is known as hybrid overlay. Today is a hybrid world where we should not be forced to use either hardware switches or the virtual switches. We should have leverage to use any of the switch. So when we get a leverage to create our VXLAN tunnel in between hardware switch on the one side and virtual switch on the other side, that is nothing but that is called hybrid overlay or hybrid tunneling in VXLAN. Hope this makes sense. My dear friends, feel absolutely free, no charge of asking any question if you have any doubt about it. Prashant, any doubt, any question? My dear friend, may I take your silence as your acceptance? Okay. So I'm taking your silence as your acceptance that it's clear, but at the same time, that doesn't mean that if it's clear to Prashant, it should be clear to everyone. I do encourage and appreciate your questions, guys. If you have any question in between, feel absolutely free to ask. No charge. Okay. So I hope three different kinds of overlays, network, host, and hybrid overlay clear. Over here, in case of VXLAN, we use different terminologies. I do remember my first interaction to VXLAN was extremely confusing. Why it was so confusing? Because the terminologies were not clear. The terminologies understood means 30% of VXLAN you are comfortable with. To sail this long journey of VXLAN, we should know the basic terminologies because over here we do have the new terminologies. First of all, those devices called the tunnel devices, right? The switches. In the generic industrial term, we call them as leaf switches. Leaf switches are the ones from where we create our tunnels, right? Say we want to create tunnels in between them. So these leaf switches from where we create our VXLAN tunnels, those are known as VXLAN tunnel endpoints. Simple. Down below our VTAP devices, we do have our endpoints. Our endpoints are in our servers. Say we do have multiple endpoints here. The holistic intention of these endpoints is to avail this tunnel facility, and in order to avail this tunnel facility, they have to enter into a segment from their legacy segment to a VXLAN segment. So what we say is these switches, these endpoints, they may belong to a specific legacy segment called VLAN, which all of us we know, but at the same time, they have to enter into another segment before being entered into the VXLAN tunnel, and this particular segment is known as VXLAN segment, where the endpoints they do enter into. Right? Isn't it confusing? That we have our endpoints in VLAN and we are making them to enter into a segment called VXLAN network segment by providing them another different ID. We know that this VLAN is an ID, right? Also known as A2.1Q, right? So this VLAN is an ID. So what we do in order to enter this VLAN into another segment, LAN segment into another segment, is to provide them with another ID. Now, here comes a question. I do deserve to ask question because continuous speaking needs a break. So guys, kindly give me a break. Let me know what is the size of this VLAN ID, and let me know what is the size of this VN ID. How many total number of VLANs we can have? All right, I give you the base number 2, and please let, I'm sorry, 1000
4095.
4095.
So in terms of VXLAN, we can use same VLAN ID for different VN ID. Like we can reuse the VLAN ID, something like that.
That is the second part of the question. Beautiful question, and it is my responsibility to address it. And that is really a very confusing statement, but very practical question, and a practical explanation is required based on the hands-on. So I would like to park this particular question.
Okay, sure.
So, but my question is, how many VLANs we can have? Answer is correct. It's 4096, which is nothing but which is the result of 2 raised to the power 12. So VLAN ID is a 12-bit VLAN ID, which gives us 4096 IDs. And you know what? In case of VNI, we have increased this 12-bit to, anybody? 2 raised to the power how much? 24. Anybody who can tell me how much is 2 raised to the power 24? It is more than 16 million. Now here I will be leaving you with a question, right? 16 million, or sometimes it's more than 16 million. Sometimes people call it as 17 million, right? And in bracket they put approximately. And if you make a real calculation, this comes out to be 16,777,216 IDs. Quite a humongous number, isn't it? What did we say? VLANs. They get mapped to these VNIs. So a big question which comes, and a very common question which should definitely pop up in our mind is, when we are doing mapping, how is it possible that 4096 IDs are going to be mapped to approximately 17 million IDs? It is a big question, and we need a thorough understanding to understand how this and what purpose for this mapping is required. That is nothing but that is we are going to understand in this beautiful journey of VXLAN. Guys, in the respect of time, right, let me first of all move back onto you guys if you have any question, and then I will present to you quickly that what different things we are going to learn in this. So first of all, any question which you have in top of mind which I can address it quickly. No question, no worries. What we are going to talk about, we are going to take a deep dive into VXLAN. As I said, we are going to learn in this particular journey a mapping. Where is my pen gone? This is my pen. All right. The mapping between 4096 VLAN IDs with 16,777,216 VN. These are called VN IDs. We are going to see how this mapping happened, what is the purpose of this mapping, what is ECMP. We are going to talk about the terminologies, first of all, to get ourselves comfortably introduced with VXLAN, comparison, terminologies back again. We are going to look at into the VXLAN packet from inside in terms of the capture of a VXLAN packet done by Wireshark. What are the different components inside it? The inside story of VXLAN, guys. There are so many things we really need, and let me tell you quickly. Okay, because we have got 164 slides to discuss about VXLAN, so cannot be possible in just 1 hour. And my responsibility towards this is, as given to me, is to introduce you guys what is we are going to study in VXLAN. And all right, the major focus of our explanation of VXLAN will be on its highly deployed scenario called MP-BGP EVPN, control plane and distribution of host reachability, wherein our responsibility will be to understand the inside story, what are different kinds of routes are there, and how the propagation of information happens in this overlay. This propagation is a systematic propagation. We are going to look at into the propagation. We are also going to look at into the output of this particular propagation with regards to one VTAP device. Very important into it. And before we come over to this, I would be expecting you guys to know about BGP various configurations. Please, right, please do support me by having a decent understanding of BGP in terms of its configuration, in terms of its attributes, and one important attribute called the community attribute. As you all know, BGP is a path vector protocol. I'm prohibiting myself from using terminology called routing. BGP can do routing, but over here we are not going to use BGP for the purpose of routing, guys. BGP is a path vector protocol. We will be using the path vector feature of BGP without advertising any network in BGP point. But at the same time, we will be using a beautiful attribute in BGP called community attribute. Probably you know that community attribute has two variants: standard community and extended community attribute. We will be talking about it. We will be looking at into the impact of it, guys. Now I have to stop myself, right? Otherwise I'll turn out to be so emotional to start talking about it. So please allow me to stop over here, and please allow me to tell you that what different gifts you are going to get as part of this particular course by the company stringnet.com. You will be requested, once you enroll yourself, the coordinator will request you to create your account in the portal called stringnet.com, wherein you need to sign up. Once you are signed up, you will get to log into your respective account. Please do intimate the coordinator or your trainer that you have created your account, so that the privileges will be given to you, your accounts will be activated, and a course will be assigned under your profile. You need to go in your profile, and in your profile you will be assigned this particular course called VXLAN, dear friends. And in this particular course you will be provided with the all the class recordings, both the theory as well as lab recordings. One more thing, I'm sorry, I forgot to tell you. During this particular journey of VXLAN, we will be taking a pause, right, in day 2 or day 3. What for? For understanding another technology called multicast. Why is it so important? Yes, VXLAN takes the help of multicast. We do configure multicast in VXLAN. So we will be taking a short break from VXLAN to give one dedicated hour to multicast. So guys, multicast for VXLAN is another session which we will be taking. You will be getting the video recording of that. Of course, you can watch them whenever, as and when you feel them good. You will be provided with the workbooks, 3 different workbooks for performing your labs: VXLAN MPBGP EVPN, D Cloud VXLAN lab guide. And the second lab, I have to present you what lab you will be demonstrated with. You will be provided with the 6 PDFs about VXLAN, and trust me, the cost of these PDFs will be more than the cost of, but whatever cost you are going to pay for this particular course. Quite expensive, and some of the PDFs, they are rare, not easily available or downloadable. And this will be our humble request to keep on sharing your feedback, right? Feedback will go to the coordinator, will go to the management. If you're happy, fine. If you're not happy, complain, but please don't keep the issues with you. All right, so this is what I was supposed to tell you. And one more thing about before winding up this session, it is being instructed to introduce you which particular lab we are going to do. Guys, once you will join us, you will be getting a privilege of 24/7, right? Anytime availability of the lab, which you can do hands-on onto. That is, the lab is called Implement MPBGP EVPN VXLAN Control Plane Lab version 2, with the topology wherein you will be provided with 2 spine switches, 4 leaf switches, 1 WAN router, which is Cisco IOS based running router. Spine and the leaf switches are Nexus OS based router, 3 Linux server 1, server 2, and server 3. Server 3 is outside the VXLAN fabric. So we have to learn the special configuration in order to make sure that this server number 3 can talk to server number 1 can talk to server number 2 and vice versa. Of course, this is going to be our second part of the configuration. Primarily, we need to make sure that server 1 and server 2 can communicate with each other, not only using the bridging, but using the routing, wherein we will prove that VXLAN provides us IRB solution, integrated routing and bridging solution. This is the lab. The complete presentation, this lab workbook will be provided to you. The complete demonstration of each and every step will be provided to you. This particular lab will be distributed into 6 different tasks. Performance of each and every task is very important. Moreover, the most important component, guys, very important component, is the sequential performance of each and every task. Lot time it being noticed that we, the network administrator, do not configure our devices in a sequential way. We do not know the nitty-gritty of certain basic commands, but we just execute the commands. Why? Because it's being said, oh, this command is important for VXLAN. So the holistic objective of this particular session is to make sure that each and every single command is well understood. The sequence of configuring those commands is well understood. Guys, time up. Time up for me to speak, and here your time begins. That's all. Please let me know if you believe that I have missed something to tell you about this particular journey. Anyone? Ah, dear friends, you are dropping. I know. Okay. If you wish to reach out right now, you can use your chat window as well. Feel absolutely free. If you cannot speak but you have some question which you would like to type, please type your concerns, your questions. My chat window is open. I can see your communication if you have any. Okay. All right. Then, my dear friends, thank you very much for joining, for giving me 1 hour of your own personal weekend time. I appreciate your presence over here. Hope to catch you soon. This particular session on VXLAN is started. Our day 1 full-fledged will be on Monday, that is 26th of this month, of course. And I wish and hope that all of us will be there. So any moment, if you have any question, any concern, you can drop on a mail, or you can have a chit chat with the coordinator. Thank you so much, guys. Once more, one time again, thank you very much for joining and showing your confidence over here. And this is Ashish Sehgal. I'm signing off. See you. Bye bye.
Thank you, Ashish.